Hello viewers. In today's video we are going to discuss about constrained motion. Basically what happens if you join any coaching centers, concept everyone teaches, but when it comes to problem solving, students are facing a lot of difficulties. So that's why I'm going to explain constrained motion of a wedge using two small illustrations. We will see two approaches to solve the same problem: how to find constrained motion, how to develop a constraint motion equation in the case of a wedge. So it is like this. There is a wedge like this, okay, and I'm keeping a mass here. So this mass m1 is sliding with v1, and because of which now this is on a plain ground. Basically what happens when it falls here, the wedge will move in this direction. So the question, this wedge mass is given as m2. The question is, what is the relationship between v1 and v2? So for this type of problem, let us say this angle is theta. What you have to do here is identify the plane which is perpendicular to the inclined plane. In that plane the velocity component should be same. Now what is the reason? Suppose you take this point actually, okay. Now this mass is in contact with this wedge. That means if I call this as x and this as y, in y direction there is no velocity actually, because the object is in rest. So we have to identify what are the components in this vertical plane, and they should be equal. So let us draw the geometry. So here let me draw a slightly bigger picture. So this velocity is in the downward direction, this velocity is in this direction, okay. This is theta, so we are interested in this plane. If this is theta, then this is theta, and this will be 90 minus theta, and this will be theta. So velocity component of v1 along let us say xx, along xx, v1 component will be v1 cos theta, which is equal to component of v2 along this dotted line will be v2 into cos of 90 minus theta, because you see this is the adjacent line, right? So this becomes v1 cos theta is equal to v2 sin theta. That implies tan theta is equal to v1 by v2. This is the relationship between the velocities. So this is called this is an example of constrained motion. The constraint here is this. Now I will explain another example. The same concept we are going to do by vectors, okay. So it is like this. Suppose there is a wedge like this, and this is a wall, and there is some rod here, rod of mass m1, this mass is m2. Rod is falling with acceleration a1. Because it is falling, this wedge will move in this direction with acceleration a2. Now this angle is theta. So what is the relationship between a1 and a2? So the same problem now we are going to solve by using vectors concept. So the sign convention I am following is, this is x and this is y. So I can say the acceleration of the rod is a1 minus j cap. The acceleration of the wedge, it is a2 minus I cap, because it is in this direction and this is in the downward direction. So here what we have to do is find acceleration of the rod with respect to the wedge, because actually there is a relative motion which is happening here. The rod is moving with respect to the wedge. So let us find out what is the relative motion of the rod with respect to the wedge. Let us calculate that. What is the formula for this? It is AR minus AW. So AR is this minus j cap minus of minus a2 I cap, right? So this becomes a2 I cap minus a1 j cap. So we got the vector, right? So we know that if a vector is given, how to find the angle? Angle is always given by tan theta is equal to the y component divided by the x component. Here I am taking the mod value. So the same expression we have done in the previous illustration also. So this is the mathematical approach. Mathematical approach. Here you find acceleration of the rod with respect to the wedge. So like this, these type of problems should be attempted. I am frequently posting videos. This is my old channel, you know. I was not posting for some time. I was working somewhere else. You can post your doubts in your comment section also. I'm going to regularly post videos and clarify your doubts. I'm going to make a lot of videos regarding problem solving, because that is where students are struggling these days. Hope my videos are useful to you. If you like the content, please share it and among your friends. And that's all I can say. Thank you very much.